This video is for Chapter 4, Section 3 of Triangle Congruence. Today we'll be looking at two of the triangle congruence postulates, which are the angle-side-angle and angle-angle-side congruence. We'll start off with angle-side-angle. Here what I have is two segments, AE and GD, which are the same length. These are congruent segments. The idea that we have here is that a person may stand at E and open up to a certain angle, and a person will stand at A and open up to a certain angle. At that point in time, we could have these two people walk, and E would continue going forever, and the A segment would go forever. But at some point in time, those two lines would cross, and therefore form a triangle. If we repeated this experiment, but had the person on the left walk at the larger angle, and the person at the right walk at the smaller angle, again their paths would go on forever, but eventually they would cross. Now, the claim is that because they walked at the same angles and started at the same exact distance apart from each other, the point of intersection, or the point where they meet, will be the same. These will form the exact same triangle. So, when I have an angle, a side, and an angle, this is called the angle-side-angle postulate. We have an angle, a side, and an angle. Get this to write correctly. So, the angle-side-angle congruence postulate, ASA, says that if two angles and the included side, let's discuss the included side for just a moment. The included side is the side that shows up between the two angles. Currently in this video, it is the only side that is solid line right now. These sides are not included between the two congruent angles. This side here is included between the congruent angles. So when we say the included side, it must be in between the two sets of congruent angles. In this picture now, triangle ACE is congruent to triangle DIG. A matches D, angle to angle. I matches C, G matches E, the angle to angle. So, this is the angle-side-angle congruence postulate. Now, in the very first lesson, we learned that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So, it turns out if we go back to that prior picture, we can look here and say, well, if B is congruent to S and G is congruent to L, well, then because of the fact that the triangles have to add up to 180 degrees, the angles, we can conclude that I is congruent to M. Anytime we have two angles congruent to two angles of another triangle, the third angle becomes congruent. Well, if this is true, then it doesn't matter which two angles are congruent. If one side and two angles are congruent, you will always have all three angles congruent. And if all three angles are congruent, well, now we would have angle-side-angle no matter what. No matter what side we mark congruent, angle-side-angle. Angle-side-angle. Maybe it's these two, angle-side-angle. So as long as you have two angles congruent to two angles of another triangle, and one side that is corresponding, you would be able to prove the triangle is congruent. Therefore, we have our final triangle congruence of angle, angle, side. Any two angles and a side that is not included. See, this is not ASA. This is angle, then another angle, then a side that is not included. So, if two angles and a side of a triangle are congruent to two angles, and the corresponding side. Now it has to be corresponding. In just a moment I'm going to show you an example of angle-angle side where the sides are not corresponding and the triangles are not congruent. But if the side is corresponding, meaning same location, then that is enough to prove the triangles are congruent. Now let's take a look at a few examples of how we might use this material. Here we have a few examples of how we might use this material on our assignments. First, the question is, are these triangles congruent and why? We should follow the same three-step process. Mark what's given to us, mark what we know, then make a decision. Currently, things are already marked for us in terms of given. These sides are congruent, these angles are congruent. I should mark things that I know. For example, parts they share, vertical angles, things that may not be given, but we definitely know. So I will add markings for BC to be congruent, BD to be congruent to BD, reflexive property. And then I could also say, well, this is angle side side. That's bad. That's not what we want. So I'm going to get rid of that marking for a second. And I'm going to say, I see a large isosceles triangle. There's something else I know. Angle A is congruent to angle C by the isosceles triangle theorem. Now instead of angle side side, I see angle, angle, side. AAS. There are two sides in succession, congruent, or two angles in succession, then a side. Now, it is corresponding here that angle, angle, and it's the matching side. So, we can say triangle ABD is congruent to triangle CBD by angle, angle, side congruence. There's our first example. Second example. Well, let's see. What do we know in this problem? AH bisects angle MAT. So, angle MAH is congruent to angle TAH. We also know that AH is congruent to itself by the reflexive property. Now, this leaves us with a lot of different options. If these two angles were congruent, we would have angle side angle. If these two angles are congruent, M is congruent to T, then we would have angle angle side. Maybe MA would be congruent to TA, and we'd have side angle side. We need another piece of information. So I'm going to add and angle THM. So AH bisects MAT and THM. Now we have angle, side, angle. So triangle AHM is congruent to triangle AHT by angle, side, angle. Alright, so there's our second example of how we decide if triangles are congruent. Third example here, I have marked up that angle B is congruent to F, and I have C congruent to D, and I have side BA congruent to DE. This looks like angle, angle, side. Angle, angle, side. And here's angle and another angle and a side. This looks like angle, angle, side. However, there's a problem. This side is connected to the double angle mark, and this side is connected to the single angle mark. The congruent side is not corresponding. Therefore, not congruent. And we're done. These triangles are not congruent, so we move on. We cannot prove them to be congruent. We say that they are not. Finally, how would we use this in a proof? Well, let's follow through the procedure. Angle B is congruent to angle D. Mark it. C is the midpoint of BD. Well, we need to mark this. So C is the midpoint of BD. I'll say here that means this is a midpoint of BD, which makes BC congruent to DC. Lastly, I need to mark things that I know. Well, that's the given, and I know vertical angles are always congruent because I have some vertical angles here. So now I can look at the picture and decide, are these triangles congruent? Yes. This looks like angle, side, angle. A, SA. So now we can write our proof. First of all, angle B is congruent to angle D. That was given to us, and that represents one angle. So now we need the side. So I'll say that C is the midpoint of BD. Now this didn't say that sides were congruent, so I need to move on and take another step and say that BC is congruent to DC. Now I've got myself that side, and this is because of the midpoint, so I might as well put in these reasons. 2, this was given to us, and because it's the midpoint, well, then the parts are congruent. Well, that's the definition of a midpoint. That's what a midpoint does for us. Awesome, we have angle, we have side, we need another angle. Well, before the angles can be congruent, angle BCA and angle DCE have to be vertical angles. We need to know that, because once we have vertical angles, we can say they are congruent. BCA congruent to angle DCE. Okay, so our reasons now. We have, by definition of vertical angles, meaning we look at the picture and we decide these are vertical angles, so they meet the definition. Now that we have vertical angles, we're allowed to say they're congruent because the vertical angle theorem says all vertical angles are congruent. But you have to have vertical angles in order to use this. Now, that's another angle statement. I have now talked about an angle, a side, and an angle. I look at my picture, angle, side, angle. So, triangle ABC is congruent to triangle EDC by the angle, side, angle congruence postulate. This is an example of how we might use the angle, side, angle postulate in a proof. Angle, angle, side would be used the same way. We would just talk about the order in the picture being slightly different. That's it for Chapter 4, Section 3. You are now ready to work on its assignment.